All right, look on page 336, one book problem.
Can you still into it? This was in my book.
Is that the rest of it?
Yeah. Sorry. I was like, I thought I finished it.
You went from a 9 to a 12.
That's fine.
All right, example 6, coasting to a stop for a 50-kilogram ice skater. And your problems will all have masses in kilograms. That's what works in the equation. The K, so they're going to give you K, which is really nice. It's very math booky for them to just tell you what the K is. It's about 2.5 kilograms per second. So this is in equation 2. So on the previous page, another version of exponential equation. This is coasting to a stop. So we're actually going to do this. We're going to do this in a lab activity in like May, where somebody in here will be given a speedometer or GPS, and you'll be riding a bike, and we're going to predict using this type of a problem when you will come to a stop on the bike by finding the limit as time goes to infinity. So this will show up again. In A, how long will it take the skater to coast from 7 to 1? So we're starting with 7 and we're becoming 1. So this is just pretty straightforward. Our K is 2.5 and our mass is 50. So just solve for time. You don't have to do that, but the book will, it's 38.9 seconds. So based on this model, if we start at 7, how long will it take to get to 1? And we're in meters per second. It would be 38.9 seconds. Okay, pretty straightforward. Second part of the question is more interesting. How far will the skater coast before coming to a complete stop? All right, so our velocity equation is 7e to the negative 0.05, I guess that's when you hit dividing t. So that's our velocity equation. So we want to find the total distance. Okay, the distance traveled completely. So in order to do that, we would have to integrate it. So our distance, or our position, is, what's this integrated?
140 e to the negative.
All right, so that stays the same. This floats. Now we're going to have to divide by negative 0.05. What's that, negative 140?
Yep.
E to the negative 0.05 t plus c. And what is my position when time is 0? We'll just say 0, 0, right? So this is 0 when our time is 0. So c equals 140. So my position is negative 140 e to the negative 0.05 t plus 140. All right, so if I want to know my position when time is 5, I could plug it in there, and that's the location where you would be based on this model. If I want to know the time when it's, or the position when time is 100, you could plug that in. Well, we want to know when you completely come to a stop. So what would my time be then? Right, a really big number, right? So we might as well just find the limit of our S equation as t goes to infinity. And that'll give me the largest distance possible based on this information. Okay, so what happens to e to the negative 0.05t as t goes to infinity? What happens to that little component here?
It's closer to zero.
It gets, this is exponential decay, so it's going to go closer and closer to zero, so it actually becomes zero as t goes to infinity. So this whole quantity here goes to zero. So 0 plus 140, we get 140 meters. Okay, so this is coasting to a stop. You should travel 140 meters. And that's what we'll do outside on our bike. We'll predict when we'll come to a stop and then compare our results with what we get mathematically. Questions on stuff? You can skip 1 and 3. Is that, are they in your assignment? Or did I not include them? Yes, no?
Where do we get it at 7?
Do you still have your packet, chapter 6 packet?
Yeah. Yeah, they're in, just give one over.
What kind of student do
Oh,
you think?
yeah, skip 1 and 3. You want me to write it in the board?
Yep.